What a great day for a virtual tour of BIG KAISER. Unfortunately, due to the recent outbreak of COVID, we're not able to host anyone this year. However, let's take a look inside our company and get a special tour. Hi, Chris.
Welcome
Good
to
to see
BIG
you.
KAISER. I'm Chris Kaiser, and I'd like to take you on a tour of our facility today. As you can see, we're in the front lobby, and I'm going to take you down into our showroom to introduce you to our engineers and product managers. At this point, you all know we are on lockdown. That's why we have to do it this way, and we appreciate that you're joining us today for this improved or new version of Breakfast and Learn. Thank you. Follow me. Hi, I would like to welcome you all to our showroom here. It's 5,000 square feet. We exhibit all of our product lines that we sell, from boring tools to BIG DAISHOWA tool holders to SPERONI tool presetters, tool, zero-point locking systems, as well as SPHINX drills. We have our product managers present here in the showroom, and they will introduce you to their different product lines.
Hi, I'd like to introduce you to Matt Tagelman. He's our product manager for KAISER Boring Systems. Hi, Matt.
Hi, Mike. Today I'd like to talk about our developments with our EWE digital boring head program. Here we have an EWE digital boring head, and you can see the display on the head showing display increments down to 50 millionths on diameter. And that's just an incremental value of the adjustment. If we pair it with the BIG KAISER app shown here in the background on this tablet, we can input information such as target diameter and tolerance. And given that information along with the last measured cut, we can use the app to show the next output diameter of the head when an adjustment is made. So as you zero out the display, the app screen switches and shows a dial gauge view as well as the output numbers for the next cut. Some other added features to the app include insert wear tracking, which can be turned on and off, as well as display settings for the head. The head units can be changed from inch to metric values. Looking at other EWE heads in the family, we have the Series 112 small diameter heads, currently in sizes 2 to 32 with CK5 connection and 2 to 152 with CK6 connection. The CK6 head can also accept side-mounted insert holders for added versatility. We're currently working on downsizing the digital program to include heads all the way down to the EWN 04 to 7, the smallest production boring head on the market. Over on the intermediate finishing side, currently we have EWE 41, 53, 68, and 100. We will also be downsizing this program to include down to the CK1 heads, EWE 20, 25, and 32, covering down to diameters 0.787. And be sure to stay tuned to BIG KAISER this fall when we release our EWA 68 boring head, capable of closed-loop boring cycles. That's the latest from the CKB modular tooling system. Thanks for visiting BIG KAISER today.
I'd like to introduce everybody to Mr. Alan Miller. Alan is our product manager for BIG. He is also the engineering manager for BIG KAISER. Thanks, Alan, for joining us this afternoon.
Thanks for taking the time. So, As part of BIG KAISER, we offer quite a number of tool holder taper interfaces. For example, we have 34 different combinations of steep taper, HSK, and CAPTO tooling available to us. Starting with the steep taper, we offer BIG Plus and standard versions of BT, CAT, and DIN SK types. We also offer C4, C5, C6, and C8 CAPTO polygon tooling. For the HSK, we go as small as HSK E25 up to HSK A125 series as a standard. And with CAT tooling, we have CAT 40, CAT 50, and BIG Plus CAT 40, CAT 50. Then we also offer the newest generation of the ASME standard, which is no longer reduced past the V-groove. We call it a high rigidity type. With the change to the ANSI standard, these types of tools are now readily available. With BIG Plus, most major machine tool builders are now offering BIG Plus spindles as a standard. Companies like DMG Mori, Akuma, Mazak. But the nice thing about BIG Plus is the interchangeability. If we have a BIG Plus tool and a BIG Plus spindle, we make both taper and face contact. We have a standard spindle and a standard tool. There's the traditional gap that you see. With BIG Plus, standard spindle can still accept the BIG Plus tool. The gap will just be a little smaller, and conversely, you take a standard tool, a BIG Plus machine can still accept that into the spindle. But when you need the extra accuracy or repeatability or rigidity, you can purchase BIG Plus tools to make that connection.
Thanks, Alan.
Thank you.
I'd like to introduce you to Cory Cetkovic. Cory is our product manager for SPHINX product out of Switzerland. Cory, can you tell me something new about SPHINX and BIG KAISER?
Yes, thank you, Mike. SPHINX is a Swiss manufacturer of precision cutting tools with a focus on diameters smaller than 3 millimeters. Standard product offering includes micro drills designed for maximum tool life, accuracy, and process reliability in the smallest diameters. There's more than 15 different standard geometries included in the micro drill program that accounts for more than 1,700 different standard micro drills. Some parameters of this program include a minimum diameter of 30 microns, coolant through available with diameters beginning at 1 millimeter, maximum drill depth of 80 times diameter, and the utilization of modern coatings designed specifically to optimize performance of micro tools in some of the most challenging applications. Also included in the standard product line is micro end mills, or precision cutting tools capable of increasing productivity and meeting some of the most challenging application requirements. SPHINX micro end mills are available for diameters ranging from 0.1 to 3.0 millimeters, most of which have a 3 or 4 millimeter reinforced shank. The micro end mill program includes more than 13 different geometries that account for 2-flute, 3-flute, ball nose, as well as specialty cutters. The SPHINX product line also includes high-performance drills. These tools are available for diameters ranging from 1 to 20 millimeters and flute lengths ranging from 3 through 30 times diameter. These tools utilize modern coatings suitable for most common and exotic materials and support coolant through for the vast majority of the drills. Most geometries can be reground and recoated to further decrease cost per hole. Lastly, we have drill reamers, or tools that can be used to both drill and ream a hole to produce a hole tolerance ranging from H7 to H9. These tools are often also used in situations that require a very fine surface finish that they're able to achieve using anywhere from 3 to 6 guide margins.
There sure is a lot of tool holder types to choose from here at BIG KAISER. How do you decide?
Thanks, Mike. Well, let me tell you. Here we have a display with BIG KAISER's core collet holder programs. Each of these programs is available in a number of different spindle interface configurations, such as CAT, BT, HSK, CAPTO, and straight shank. It's also worth noting that all of our collet holder programs guarantee 1 micron of runout at the nose and 3 microns at 4 times diameter. Our first collet holder program is called the Mega New Baby, also known as the Mega N. The Mega New Baby program has a clamping capacity of 0.010 of an inch to 1 inch in diameter, or 0.25 millimeters to 25 millimeters. The Mega New Baby program is BIG KAISER's flagship collet program and our first choice for most milling and drilling applications. Next, we have BIG KAISER's Mega ER program. The Mega ER program has a clamping range of 75 thousandths to 0.787 inches, or 1.9 millimeters to 20 millimeters. The Mega ER program complies with the industry standard with one exception. The length of BIG KAISER's collet bore has been increased to accommodate a 1 micron runout accuracy. A result of this is only a 0.5 millimeter collapsibility for each of BIG KAISER's collets when they're used with a BIG KAISER holder. Next up, we have the Mega Micro program, also referred to as Mega S. Mega S is available with a clamping range of 0.45 millimeters to 8.05 millimeters in 3 different body configurations: a tapered body, a cylindrical body, as well as a straight shank. Mega S is often our first choice for drilling applications due to its low cost, as well as a first choice for milling applications where a long-reach, slim design tool holder is necessary. Lastly, we have the Mega E program. The Mega E program has a clamping range of 1/8 of an inch to a 1/2 inch in diameter, or 3 to 12 millimeters. Mega E is our first choice for milling applications using cutting tools smaller than a 1/2 inch. Mega E has some specific characteristics incorporated into its design that allow for improved performance in milling applications. First and foremost, this tool holder uses a tapered body to enhance rigidity. It also incorporates a longer collet into its design to improve the gripping strength. And lastly, the threads between the collet nut and the tool holder have an increased thickness to further enhance rigidity. Here we have a display highlighting some of BIG KAISER's additional tool holder programs. First, we have the High Power Milling Chuck, or HMC. The HMC has a clamping range of a 1/2 inch to 1.5 inches, or 12 millimeters to 42 millimeters. The HMC offers our highest gripping force possible for rough end milling applications. Next up, we have the Mega Double Power program, also known as the Mega DS program. Mega DS holders have a clamping range of 5/8 of an inch to 1.5 inches in diameter, or 16 millimeters to 50 millimeters. Mega DS is very similar in design to HMC with one exception. The body of the holder has been cylindrically ground to permit high-speed machining. Lastly, we have a very diverse program of hydraulic tool holders. BIG KAISER's hydraulic tool holders have a clamping range of 1/8 of an inch to 1.25 inches in diameter, or 3 millimeters to 32 millimeters. BIG KAISER hydraulic holders are available in a number of different taper interfaces that include HSK, CAPTO, BIG Plus, as well as straight shanks that are suitable for Swiss machining. BIG KAISER's hydraulic chucks are also available in a number of different configurations, such as a super slim design, a high rigidity design, as well as jet-through coolant. BIG KAISER also has a diverse program of shrink fit holders available in a variety of taper interfaces that includes BIG Plus Cat 40 and BIG Plus Cat 50. Shrink fit holders are often selected by customers who already have a shrinker and are interested in tool holders with a slim body design or ultra-low runout. There's concerns with quality and performance over time. Shrink fit holders are difficult to maintain micron-level runout after hundreds of heating cycles. These holders are often overheated or cooled too quickly, resulting in changes to the material properties of the holder. It's really necessary for someone to monitor the heating and cooling cycles in order to retain the original runout guarantee.
I'd like to introduce you to John Zaya. He's our product manager for UNILOCK Workholding.
Thanks, Mike. So we'll be looking at UNILOCK, which is a 0-point fixturing system. We'll be looking at bases, pallets, as well as our 5-axis offering. So let's take a look at our demonstration table. The UNILOCK system is composed of 2 primary components, the clamping knob and the clamping chuck. The knob is attached to the underside of your pallet or your fixture, and the chuck is installed onto a base on your machine table. When air is applied, the chuck opens and your fixture is now allowed to be installed, and it will locate within 5 microns or 2/10,000ths of an inch. The fixture can also then be taken off and moved from one machine to another without having to remove the part from the fixture itself. Let's take a closer look at some of the important features of the UNILOCK clamping knob. Here we have the locating taper, this is the locating pilot, and here we have the clamping lip. The locating taper seats the knob into the chuck on the chuck's locating taper here. The clamping lip is grabbed by the 2 clamping pins inside the chuck, and the locating pilot is counterbored into a bore on the underside of the fixture. So for example, here we have a reduction with a clamping knob attached. When we insert the reduction into the chuck, the taper of the knob is now located on the taper of the chuck. When we release the air pressure, the chuck is now clamping onto the retention knob and holding it in place. And then we can pull it out whenever we want in order to release the fixture. The UNILOCK 5-axis program is composed of various styles and heights of bases, various heights and styles of extensions and reductions, all of which allow you to stack and reconfigure the system as needed per your requirements. For 5-axis machines, the primary benefit comes from elevating the part off the table of the machine, which allows for clearance of the spindle housing. Elevating the workpiece also allows you to shorten long tools down to more appropriate and better performing tool lengths.
This is Nick Jew. Nick is an R&D specialist for BIG KAISER Precision Tooling. Matt said I should ask you about some automatic fine boring tools.
Sure. So this is our prototype of our newest lineup that we're hopefully featuring in this fall. It's called our EWA lineup. It'll be a fine boring tool. However, instead of a manual dial on here, it'll be an automated motor system. So there are a few motors built into this head that allow for an automatic adjustment of the insert holder for whatever diameters you need to set to. For example, I will set this. I have it connected currently to a tablet. It can be connected with your phone or tablet. And I'm gonna send a command to make an adjustment. I'm doing a large adjustment, so if you wanna come in close, you could probably see that this insert is moving out. Right now, all automatically. No adjustments need to be made by the operator. Everything is connected wirelessly via Bluetooth, just like our EWE tools that we have currently, and it will use our same exact boring app as the current system that we have. It'll allow for simple drop-in replacements from our digital boring heads all up to the automated boring heads. So these automated boring heads, we are currently in production and development and producing for these, testing, doing trials for it. They can be connected via smartphone or tablet, as you see here. Another thing is that they can be connected to a computer, an external computer connected to, say, the machine control. This allows for a more closed-loop boring cycle. So the tool will communicate with this computer, the computer will translate this information to the machine and vice versa. This is perfect for legacy machines that don't have network capabilities or a control that is a little bit older and can't support third-party integrations. And of course, the third option would be to have the controller directly communicate with this head. So this head, since it's Bluetooth connected, any control that has Bluetooth capabilities or allows for like a USB connection or network connection even, will be able to communicate with this head directly and do automatic closed loop boring. So that's a sneak peek into our upcoming future tool. Hope you enjoyed.
Thanks, Nick.
Yeah.
Hi, Pat.
Hey, Mike.
I'd like to introduce everybody to Pat Karate. He's our assistant product manager for tooling measurement systems. Pat, can you show us something new as far as presetters and what BIG KAISER offers?
Absolutely. We are looking at the SPERONI Essentia. This is the latest model released by SPERONI. It is supposed to be our introductory model. So those people who don't really need something very large and want to get into presetters, especially if they're new, this is a great option. Benchtop unit, constructed with cast iron, still uses the vision system, same one that we use on the other larger SPERONI models, and still has the same full-featured control software that we have also used on the other SPERONI models. On this machine, we are able to measure height, diameter, runout, print a label, attach it to the tool, or we still have our functionality of being able to export this out to the machine center control via G-code, program file, CSV file, or something similar. One thing I'd just like to mention, even given the size, this can still be on the shop floor, or it can be in a tool crib. You know, once again, reiterating the fact it's a cast iron machine, but we still have the same construction materials like we do on the other ones. Schneeberger guideways, Heidenhain scales, once again, that same vision system that we're using on the other models.
But Pat, what if somebody would want a larger presetter? Something maybe for the tool crib to preset tools. Will this fit that bill, or is there something else that they can move into?
It can, so it could still fit in the tool crib. It just depends on what their needs are. So one thing that people might be looking into would be potentially a little bit larger machine. This is a SPERONI Magis, the next size up. Once again, still a benchtop model, still a cast iron construction, but about twice the amount of cast iron on this one. And we have some different height ranges in the Magis, so we can do a 16, 20, 24-inch option. The Essentia, we are capped at the 16-inch limit. Major difference between the two other than size, this machine is modular. So we can have an option, for example, like a retention knob clamping system. It's a true retention knob clamping system, a mechanical clamping system. It's not vacuum clamping, for example. It's also modular in the fact that we could add additional camera systems, multiple camera systems. We can upgrade the software to be more of a data-driven software. If someone's trying to have a tool library held inside the control, we have multiple options and different layers of that to help you accomplish what you might be looking for. Other modular features we can add. Here's a Balluff RFID system that we have equipped on this one. We can also do PNF, as well as things like Mazak Cyber Tool. We'd also offer CAD CAM and Vericut, anti-crash simulation software that we can do. We also have the ability to go fully automatic on this machine as well, so we can do a full CNC version of the Magis here.
That's great, Pat, but what if I still would want something larger? Say my volume of tools that I have to set is increasing. I'm doing maybe 100, 200 tools per day. I'm supporting several shifts. Is there another presetter that I should maybe be looking at?
There is. So this model is called the Futura. As you can tell, it's larger, and that's the whole point. We can do a wide variety of size ranges, going all the way up to 48 inches height, 48 inches diameter, if that's really what you need. Of course, the other big difference here is it's just a beefier machine. You're going to be able to put more tools through it on a daily or per shift basis, and it's going to stand up to wear and tear just a little bit better, especially in those high production environments. Another major difference between the Futura and the other models is this has a quick change adapter system. On the Essentia and the Magis, we're going to typically start with a 50 taper reduction spindle. A 50 taper spindle, and we'll use the reduction adapters to reduce down from there. Here, we just have a 3-pad mating surface with a cam lock system. So this way we're not losing any height between the adapters. We're not losing any accuracy between the adapters. In fact, we're able to calibrate these down to 1/10 runout per adapter at 15 inches in height. This machine can also be fully automatic or manual, as well as an automatic shrinker system that we can equip with this as well.
So Pat, how would I see a demo given this time? Is that something that's possible?
Absolutely. Right now, obviously for safety reasons, we are doing the virtual GoToMeeting, Microsoft Teams, Zoom type of web demonstration. And the way we do it is we set up a camera, point it at the machine so you can see it and see us interact with it, as well as we do a live screen capture of us working with the control software so you can see both aspects of it. It's about as good as you can get without getting hands-on.
Great. Thanks, Pat. Thanks for your time. I appreciate it.
Absolutely. Thank you, Mike.
Hello, my name is Zach, and I'm a repair technician here at BIG KAISER, and welcome to the BIG KAISER Repair Department. Over here, we repair big DAISHOWA products, such as angle heads, spindle speeders, and coolant inducers. We keep a fully stocked inventory of repair parts to ensure quick turnaround times. Over here are our spindle masters, which are precision measuring devices, which we use to check runout of our tools. Over here is a custom-built test stand, where we check our angle heads and spindle speeders for temperature and noise. Over here is our balancing machine, where we balance tooling assemblies. On this side of the room is our BIG KAISER boring head repair station, where we repair boring heads from small diameter all the way up to large diameter. We also keep a fully stocked inventory of repair parts to make sure we get repairs out on a timely manner. Over here, we repair our UNILOCK Workholding systems, and to the side and behind me is our machine shop, where we use our machines for repairs, modifications, and to create custom fixtures. And that is our repair room. I hope you all have a great day.
Thanks for coming back and joining us for our tooling and work holding 5-axis presentation. Please join us.
Thanks, Mike. Nice tour and a great intro to some of our employees and products here at BIG KAISER. Welcome to our training room. My name is Jack Burley, Vice President of Sales and Engineering for BIG KAISER. Today's webinar is about 5-axis strategies for tool holding and work holding, presented by Zaya and Cory Cetkovic, product managers and engineering support for here at BIG KAISER. Of course, major decisions about work pieces and machine selections, as well as CAM software, are all very influential to the overall productivity of 5-axis machining. But strategies for using the right fixturing and tooling can make or break higher speeds and feeds. Switching from vertical machines to 5-axis machines truly requires new ideas if you want to maximize efficiency and cycle time. John will start the presentation and show the different types of 5-axis machines and suggest better ways of holding work pieces and work holding equipment. Cory will then discuss some of the trends in cutting tools and tool holders unique to 5-axis applications. Please submit any questions you may have and we'll answer them at the end. We look forward to this presentation. John, take it away.
Thank you very much, Jack. Welcome everybody. I hope everybody's doing well today. So to start, I'll generally look at talking about a little bit of terminology in order to help those who are new to 5-axis machining, as well as for those of us that have been doing it for quite a while, so that everybody's kind of on the same page. So we'll look a little bit at terminology. We're also going to review some of the machine types that are available out there. We'll also discuss some of the common interference areas and issues that are prone to 5-axis machining. And then we'll take a look at both some work holding solutions as well as tooling solutions to solve these problems. So to start, 5-axis machining is generally considered a complex surface geometry machining operation. The workpiece is not prismatic. It is generally, as you can see with some of these examples here, a very complex surface part that has geometry that cannot be created with just standard linear movements of the machining center. Common workpiece examples include impellers, blades, medical, molds, and aerospace components, all of which require the generation of surfaces that are required to use both the movement of the machine in both linear movement as well as rotational or tilting movements. The surfaces themselves can be varied in terms of their size and complexity, but generally the requirement is that it must be moved in a movement pattern that cannot be generated with only 3 axes. The second form of machining that we'll see on a 5-axis machine is also called 3+2 or 5-sided machining. This is generally when we're going to be working on a workpiece that is more prismatic in such that the workpiece itself doesn't have complex surfaces that are being generated by the machine, but requires positional accuracies or positions that would require multiple fixtures in order to hold the workpiece in location to generate the features. So examples of these types of workpieces are gear case housings, valve bodies, and the examples that you see below are cast components that have complex surfaces, but none of those surfaces are being generated via 5-axis machining. The features being generated would be, for example, the bores or holes or tapped holes, or simple pockets that just require the workpiece to be repositioned. These types of applications are very efficient when done on a 5-axis machine because it eliminates the requirement of having multiple fixturing to reposition the workpiece. We're going to discuss certain types of machines. There's 2 basic types. The first one is called the trunnion style machine, and this comes in 2 variants, the horizontal and the vertical variant. Obviously, with the horizontal, the machine spindle is horizontal to the ground, and the vertical, as its name implies, the spindle is vertical to the ground. Both of these combined, both of these have the ability to have a workpiece rotate and tilt about its own center line as needed. And this gives a lot of flexibility to access the workpiece at both its primary faces as well as in some cases along its edge or bottom faces. These types of machines are commonly called table and table configurations and are very much better for heavier cutting operations. The spindle is much more rigid and can be higher performing when it's set up with a belt or gear driven spindle. The slightly greater flexibility of the table allows for easier undercutting at the bottom of the part while maintaining full travel capability. The second style of machine that we commonly see is called the universal head type. This configuration has a table that only rotates and the head pivots. This allows for larger parts which could have been limited by the width of the trunnion style machine. This is commonly referred to as a head-head or head table setup. It can suffer from some limitations as the tool and spindle combination can consume some of the machining volume as the head tilts. It should also be mentioned that there's a third style that uses a gantry mounted universal head, where the part is fully stationary and the head moves entirely around the part. This is very common for very large mold and aerospace part production. In these 2 examples, we see both styles of machines, the trunnion as well as the universal head style, and both of them are going to suffer from limitations caused by the spindle housing diameter size, as well as the table size. In both cases, the workpiece is fairly small and the table is a very large diameter. The spindle housing, also a large diameter, will cause an interference or a limitation as to how close it can come to the machine's table. This limitation is common amongst most 5-axis machines and is usually very well documented when a customer purchases their machine, and should be taken into account when they're planning their processes for their workpiece. So the question then is what happens when you have a large table and a small in a small workpiece. What issues does this lead to? Commonly, what will happen in order to solve this type of problem, customers will use a much longer tool holder or a longer cutting tool in order to reach the features they're trying to achieve. This will then cause lower feeds, lower speeds, lower depths of cut, which then leads to increased number of passes, as well as increased program sizes as well. All of this leads to a more chatter-prone cutting operation, which then requires either more handwork to finish surfaces or increased production time. When we're looking at work holding on 5-axis machines, many of the traditional methods for elevating the workpiece off the table include vices with quote-unquote tall jaws. Their purpose for this problem is to solve the they pose their own problems as the clamping spindle may be very far from the jaw, reducing the effectiveness of the clamping system. Even worse is if the jaws are too tall, then they can be more susceptible to tilting, causing the part to squeeze out of the jaws. Here we also have a good example of how a modular work holding system can be used to allow you to put the workpiece anywhere on the machine table. The example on the right shows a stack of UNILOCK 5-axis modular components that are off center of the machine table. This allows you to adjust your offsets as needed in order to put the workpiece wherever it might be most convenient or safe for operation. In this example, we have a traditional 4-axis horizontal machining center making use of the UNILOCK 5-axis program to elevate the workpiece off the top of the table or the machine pallet. Even in this type of application, elevation is needed because the spindle housing has its own limitations to the machine table. This is a common interference problem that can be addressed with many options, including monolithic risers or modular riser systems. Here we have 3 different examples of 5-axis workpieces. Starting from the left, we have a very small part that is held onto an adapter that allows it to be held and presented to the spindle of the machine in such a way that it completely eliminates most, if not all, obstructions to the spindle housing. The center example shows a medium-sized mold being machined without having to push the spindle into the workpiece. The tool holder is able to do all of the work that it needs to and provide as much clearance as possible. And on the far right, we have a very large workpiece, again, elevated off the table of the machine in order to provide clearance to all faces that are needed to be reached. Another offering from BIG KAISER is called the UNILOCK Flex system. It uses a clamping ball attached to the workpiece and can accept parts that are not flat. With fixed length bases and extensions, as well as adjustable versions, a part can be dialed in to place if needed. Even with very flexible work holding system, some parts still need to be mounted directly to the machine table. That is when proper tool and tool holder selection becomes critical. And I'll let Cory discuss the rest of that for you. Thank you.
Thanks, John. It's evident work holding has a significant impact on tool holder selection for 5-axis machining. My name is Cory Cetkovic, and the following slides focus on tool holder selection for 5-axis applications. First and foremost, tool length should be kept to minimum requirements to get inside the workpiece, not necessarily to the workpiece. As seen in this example, the tool holder assembly must be able to reach the innermost geometry of the workpiece. Due to practical movements of the machine, 5-axis tool holders are often longer than similar holders used in 3-axis machining applications. As John alluded to, 5-axis risers and reducers, as well as other work holding systems, can be used to permit shorter tools. In many cases, raising the workpiece off the table reduces the required tool length to reach the workpiece's innermost geometries. On the next slide, we have some of the common milling tools used in five-axis machining applications. Circle segment cutters, also known as barrel cutters, are very popular and modern in five-axis applications. They're available in 4 different configurations. The main purpose of this style of cutter is to have an increased contact diameter with the milling surface, and it allows for reduced cycle time and improved surface finish. Then there's tapered end mills, which is effectively end mills with a conical shape, ball nose end mills, high helix roughing end mills, multi-flute finishing end mills, micro end mills with reinforced shanks, and coolant through end mills. There's clearly some synergy between 5-axis and 3-axis cutting tools, with the exception of a couple specialty cutters, such as circle segment and tapered end mills. It's worth noting that in many 5-axis machining environments, you're able to use these tools in maybe a different way than you would in a 3-axis machining application. And this is especially true with something like a ball nose end mill. So that brings up the question, what's the best tool holder option? The first type of 5-axis tool holder technology we're going to cover is shrink fit. Shrink fit holders are a single piece design manufactured from premium tool steel, such as H13, to cope with an indefinite number of thermal cycles. Shrink fit holders are most commonly used in moderate to heavy milling applications. Due to their slim body design, they're also used to access confined spaces in long reach applications. This is a very popular technology for both 3-axis and 5-axis machining. On the bottom half of this slide, we have a chart with some tool holder characteristics. BIG KAISER shrink fit holders have a runout accuracy of 0.2 on diameter. This is adequate for most applications. The SR ratio, or slenderness ratio, is 1.7 to 2.7, depending on the style of holder. There are various body diameters and styles available within the shrink fit program. We will compare this number with that of a different tool holder in a few slides. There is no clamping range, and what I mean by that is shrink fit holders are designed to clamp only one shank diameter within a very specific tolerance range. A 1/4 inch shrink fit holder can only clamp a 1/4 inch cutting tool shank. Gripping power is considered strong. Pull-out security is moderate. This is because there's no mechanism capable of locking the tool inside the tool holder assembly. Shrink fit holders have excellent performance in high-speed applications due to their symmetrical design. On the other hand, they're relatively poor at dampening vibrations due to their slim monoblock design. Handling is also considered poor due to the process required to change a tool. For those who are unfamiliar, the tool holder is heated until the clamping bore expands to the point that a tool can be changed, at which point there is a controlled cooling cycle to shrink the bore back to its original size. During our showroom tour, I briefly mentioned that it's necessary to use controlled heating and cooling cycles to maintain runout accuracy and gripping strength after many tool changes. Here we have a graph comparing gripping strengths of various shrink fit holders. The 2 bars on the left-hand side are conventional standard body design holders, and the 2 bars on the right-hand side are slim body holders. These holders have a smaller body and nose diameter than the rather conventional design of the others. Within each classification, we are comparing the gripping strength of each holder for 2 types of cutting tool shanks. The first type has a nominal diameter or 0 tolerance, and the second type has an H6 tolerance. In this case, an H6 tolerance is plus nothing minus 0.4 of an inch. And this is a very common tolerance that you'll find on various manufacturers' cutting tool shanks. There are additional tolerance classifications between H6 and 0 that further reduce the tolerance beyond 0.4 of an inch, as seen in this example. So there is H5, H4, and so on. It's evident that gripping power is dependent on the cutting tool shank tolerance as well as the outside body diameter of the holder. The conventional shrink fit holder using a tool with an H6 shank tolerance results in roughly 100% gripping strength. So the conventional body holder with an H6 tolerance shank results in 100% gripping strength. There is roughly a 30% reduction in gripping strength when switching to a slim body holder. This is a critical detail as it explains why a slim body holder should be used only when necessary. These results also demonstrate the necessity for high quality cutting tools for high performance production shrink fit applications. Using tools with inaccurate shank diameters will have a direct impact on pull-out security. This is especially true for tools smaller than 1/4 inch and especially 1/8 of an inch or 3 millimeters in diameter. In this case, for example, if the tolerance were +0, -0.8, and the shank was made to the lower end of that tolerance at -0.8, the gripping strength would reflect that. The next type of 5-axis tool holder I'm going to discuss is hydraulic chucks. Hydraulic tool holders are a modern innovation that offers some distinct advantages in 5-axis applications. These holders are suitable for cutting tools with a full round shank and an H6 diameter tolerance. Although hydraulic tool holders can accommodate various styles of sleeves, exact size shanks should be used to achieve optimal performance. In many cases, our customers will standardize a machine on one size of hydraulic chuck and use sleeves to accommodate various size cutting tools. We suggest these holders for finish milling, drilling, as well as reaming applications. On the bottom half of this slide is a chart comparable to what you saw on the shrink fit tool holder slide. BIG KAISER hydraulic chucks have a runout accuracy of 1/10 of an inch. Comparatively, shrink fit holders are 2/10 of an inch. They're both very accurate tool holders. The question becomes whether the difference in clamping accuracy grows, shrinks, or remains the same after hundreds of tool changes or clamping cycles. In many cases, I would expect the hydraulic holder to retain its original runout accuracy over a long period of time. This is less likely with shrink fit technology. The slenderness ratio is 1.5. I briefly mentioned that most hydraulic chucks can accommodate sleeves to increase the clamping range, so this is considered a plus. Gripping power is considered moderate. It's really adequate for the applications that they're intended for, finish milling, drilling, and reaming. If gripping strength is an issue, either the program is too aggressive or a hydraulic tool holder is not the best selection for the application. Pull-out security is considered moderate. This is comparable to shrink fit. Neither holder has a mechanism capable of locking a cutting tool inside the tool holder, or ultra-high gripping strength like a milling chuck. Hydraulic chucks are rated good for high-speed machining. There are different styles of hydraulic chucks, some of which are suitable for speeds as high as 60,000 RPM. Hydraulic holders have excellent damping characteristics. This is an unintentional consequence of the body design that includes 2 chambers of hydraulic fluid used to clamp the cutting tool shank. There is not an internal dampening mechanism similar to what is found on our Smart Damper line of products. Handling is also considered excellent due to how safely and quickly users can change a cutting tool. Can everyone please view the tool holder on this slide? Beneath the flange is a screw seated in a counterbore. This screw is used to clamp and unclamp tools using a standard hex wrench. I consider this to be safer, easier, and faster than almost any type of tool holder. So to reiterate that, beneath the flange on this tool holder, there's a lock and open etching on the tool holder with a hex screw behind that. Tightening that screw and loosening that screw is all that's necessary to clamp and unclamp a cutting tool. Here we have the construction of a BIG KAISER hydraulic chuck. Hydraulic tool holders are designed with a monoblock structure that permits slim external body diameters. The design also allows for the cutter to be held at near nose position. Comparatively, collet holders often have a clamping area that's recessed behind a collet nut, meaning the tool holder length extends beyond the clamping area. Hydraulic holders also incorporate spiral grooves into the clamping area to evacuate oil and residue content that could influence gripping strength and runout accuracy. The holders have 2 chamber rooms filled with hydraulic fluid. The purpose of using 2 chambers is to minimize runout accuracy by clamping the cutting tool shank in 2 locations. The clamping screw is used to clamp and unclamp the tools, as we previously discussed. This screw tightens to a hard stop, at which point a cutting tool is secure. This feature is an excellent safety measure because users can be certain a tool is securely clamped. When that screw turns to a hard stop, at that point the cutting tool shank is securely clamped as long as it has an H6 shank tolerance or better. These holders require no maintenance and should not leak hydraulic fluid under any circumstance, even if the clamping screw is removed or falls out. On my last slide, I want to take some time to cover details of our super slim hydraulic chucks. Super slim holders are ideal for precision finishing processes in confined areas with drills, reamers, and various types of milling tools. We offer a wide variety of spindle interfaces, clamping diameters, and projections to fit nearly any application in automotive, aerospace, medical, as well as die and mold. On the bottom left-hand side of this slide are some ultra-compact and precise HSK holders. Smaller HSK interfaces such as E25, E32, and E40 are often found on high-speed 5-axis machining centers. These machines require tool holders with a high level of balance and adequate RPM rating. BIG KAISER's HSK E25 hydraulic tool holder program is an excellent example of our capabilities with a 60,000 RPM max and less than 0.5 gram millimeters of imbalance. So our E25 hydraulic program has a 60,000 RPM max. On the right-hand side is a super slim straight shank hydraulic tool holder. This design has a high precision shank capable of solving interference problems in many applications. In this image, it's evident that the orientation of the workpiece requires a slim design tool holder to avoid interference. Straight shank hydraulic holders permit slim designs while maintaining the vibration damping characteristics of the hydraulic bladders. So this is an excellent option to consider for customers using slim design collet chucks as well as shrink fit technology in their long reach tooling applications. And with that, I'd like to turn this back over to Jack and the audience with any questions.
Thank you, John. Thank you, Cory. Excellent job. Appreciate all the information. A lot of detail that we have to consider when we're putting a 5-axis system together. Not just the machine, as I mentioned, but a lot of work holding and tooling. But before we get into the webinar topic, there was some questions about the tour. If I could answer those quickly. 2 of them were about Nick Jew's a quick demonstration on EWA, our automatic boring tools. And one of the questions was, will these be available with our CK system? That's our modular tooling system that we've been promoting for several decades now to go with our boring tools. And the answer is yes. Most of these tools will be somewhat compatible to as many of the existing systems that we've been offering for many years. CK part of that, of course, is one that will hold to that. So existing accessories like the shanks that are available now will also be interchangeable to the new automatic system. The first generation of tools that will give to the market or sell to the market are expected to be completed in the fall of this year, with a work range from about 2 3/4 and a little larger than that, up to about 4 inches. This tool has a very precise adjustment as well as coarse adjustment. What you saw was Nick demonstrating a very large adjustment range. He was moving the tool through a very large stroke. Means that if you have one tool, it can solve several different bores in the same part or family of parts, or even in the same magazine. This means you can make a lot of different bores with just the same tool. But you can also make extremely small micrometric adjustments. So with a probing cycle or some sort of gauging cycle to the bores, which feed back to the machine and control, the tool can make micron movements, 10/10,000ths of an inch at a time to adjust for tool wear or any sizing constraints. So it's all very much an automatic system through the full range for very precise bores, as well as multiple sizes of bores. The next question was involving that same automatic boring tool. Could we do holes between 14 and 16 millimeters? With the next style of head with automatic adjustment, we're looking to make one that's similar to our small diameter heads, which covers a range from 2 millimeters to 50 millimeters. The new automatic will start at 15 millimeters and not as much travel as the larger head. It'll also have the CK connection, but it'll also have the automatic closed loop boring cycle built into it. So we expect to release more information as we get closer to IMTS, where we're looking to do demonstrations at the show, and if the show is canceled, we'll be doing that in our showroom to show the features and capabilities of closed loop boring. So on to the webinar questions, and I'll take first stab at the first one, but one of the questions was relative to the shrink power or gripping power. The question is, what's 100% gripping power? What's it compared to? What is the actual holding? So the answer to that question is those graphs were based on theoretical or nominal values that we calculate. And it's a bit of a complex formula, but some of the factors that go into that are not just the diameters of the bore of the tool holder and the diameter of the shank of the tool itself, but also things like the length of engagement of the tool to the bore. But another more critical is not just the body diameters, but the friction. Coefficient of friction plays a major role in gripping power. Polished shanks are much more difficult to hold on to than, say, a ground shank, which has a little bit more, it's a very fine finish, but it has a little bit something more for the tool holder to grip into. So those are just theoretical values. And as you can see, by changing the tolerance bands on the tool, you will start to see changes in the gripping force as well. You have to remember that there's tolerance bands inside the shank of the shrink fit tool holder as well. And certain manufacturers will open those tolerances up because it's a little easier to manufacture. And certain manufacturers will vary or have a very controlled tolerance band on the shrink fit tool holders. And the more closely we watch those hole sizes to very, very critical sizes, the more we can control that gripping force to be more consistent. So it is, of course, something in the tool, but also the tool holder and how we grind that has to be controlled very accurately. So I'll go to the next question. Does the tightening screw on the hydraulic holder need to be torqued to a specific value? Cory?
Well, you're supposed to tighten it until you reach a hard stop using a hex wrench, so there really is no specific value. It's the point at which you reach the hard stop.
Okay. The next question, what is the overall length on the super slim hydraulic chucks? In other words, what's the gauge length that they're available with?
They're available in gauge length of roughly 40 to 60 millimeters for the E25 through E40 program. They go as long as maybe 75 millimeters in length, but they're all relatively short, so less than 2.5 inches, 2.5 to 3 inches.
I think on the Cat 40, if I may, Cat 40, Cat 50, and some of the Big Plus, we take them out to 5 inches or more. Just so you know, but that's all in the catalog. We're more than happy to send you those gauge length informations. So the next question is, why is HSK seem to be more popular on 5-axis machines?
Well, I'll take that one, Jack. So the industry is really gravitating towards HSK, but there's really technically no reason. They're available, in some cases, the smaller HSK is an option for a 5-axis machine. In other cases, it may be Big Plus or even larger HSK tapers. There's advantages and disadvantages of each style, but in many cases, whether it's Big Plus or a larger HSK, they both perform very well.
Okay. Next question is maybe for you, John. How are the pull studs mounted on the UNILOCK system?
Thank you, Jack. So the UNILOCK knobs are attached to a workpiece in a couple of different methods. First, there's generally a 25 millimeter counter bore to locate the knob. And then to fasten the knob, the easiest method is to pass a fastener through the knob and thread it into the fixture. This can be as small as an M10, but more commonly we'll use an M12 or even an M14 screw if needed. Additional options allow you to come down through the workpiece and thread into the knob using the knob's nominal thread size. So again, M12, M16 are the most common options there.
Okay, thank you, John. For 5-axis machines which have a C-axis which has the ability to turn at higher speeds rather than just positioning, what are the best work holding and tooling options for doing turning ops on a 5-axis machine?
So for turning operations where you're going to be at higher RPMs than just regular standard 5-axis machining or 3+2 positioning, that's generally where the more industrial standard is to use a traditional lathe chuck style work holding system like a 3-jaw, 4-jaw, 6-jaw. Those are really designed to handle the higher RPMs that a turning operation will require. And that's where most modular systems kind of fall away because you're generally going to be dealing with round billets of material or round surfaces on a workpiece at that point. On the tooling side, that's where a lot of machine builders and tool holder manufacturers use a designation on the tools. So for example, with HSK, there's a version of tooling called HSK-T. T is for turning. We have the same versions for steep taper tooling as well. These allow you to control the angular orientation of the cutting tool relative to the workpiece. And what's really nice about these is for turning operations, it works very well. But if you're also doing standard rotating operations, drilling, milling, etc., you can still use the standard versions of these tool holders. So the HSK-A version of a tool can go into an HSKT style spindle if needed.
Thank you, John. I think I'll take the next question. Is the slim design hydraulic holder available in CAPTO? The answer to that is we do offer hydraulic tool holders in CAPTO C5, C6, and C8, but we don't offer the slim design at this point. That being said, however, we'll make anything you want. So if you have a specific need, please send us a request, and we can certainly quote specials in any of these configurations that we don't offer as a standard. The next question, I think probably for you, Cory. Could you speak to the Mega Micro tapered tool holder line in regards to 5-axis machining?
Absolutely. I think the Mega Micro is a great option for 5-axis machining due to its slim nose diameter and the types of configurations it's available, whether that's straight shank, tapered body, or a straight cylindrical body diameter. It gives users the ability to access some confined areas, similarly to what I described with the straight shank hydraulic chuck, and also with the body diameter of a shrink fit holder. The reason why people tend to gravitate towards something like Mega Micro is the flexibility that you gain within the collet system. So you can clamp more than one shank diameter with the same holder, whereas when you compare that with a shrink fit, you're really limited to one size. And then lastly, someone might select the Mega Micro simply because it's so small, and it's also one of our lower cost tool holder designs. So it does compete well with some other monoblock tool holder designs such as shrink fit.
Thank you, Cory. We have another question. In a milling scenario, how do you compare hydraulic chucks with the baby chucks or mega chucks series using the same criteria you showed in your slides?
A collet chuck has some inherent advantages. It's safe to clamp a cutting tool. There's a high level of flexibility with regards to the different shank diameters you can clamp, but where it really lacks is the pull-out security or gripping strength. That's where a hydraulic chuck tends to excel, is in the gripping strength, whereas a collet chuck excels more in the flexibility. Maybe it's better in a high-speed application due to its symmetry, but they're both used in comparable applications. I would say that the collet chuck is more suitable for drilling, and the hydraulic would be more for finish milling, as well as shrink fit.
Okay, thank you, Cory. I'm going to take the next one. What is your recommended best practice for measuring runout on a shrink fit tool in a shop setting? And the answer to that is, of course, we go back to looking at a high precision presetter like our SPERONI line. It's always best, in our opinion, every time you change a tool, no matter whose tool holder and what guarantees they might provide, to inspect runout before you put it back in the machine. That being said, if you don't have a presetter, our recommendation, of course, would be to look at one, because it is critical to your operation running effectively and efficiently. If you don't think you want to do that, then you have no choice but to measure on the machine itself, which is somewhat complicated because generally you're going to have to use some sort of dial indicator. And you could probably get away with using a very light dial indicator with very little spring pressure on tools maybe bigger than 3/8 of an inch. But below 3/8 of an inch, you're going to run the risk of deflecting the tool as you spin it around the dial indicator while it's in the spindle, which isn't going to give you a true indicated reading, and it's also a potential for some sort of damage. There's also table type presetters, but those generally only measure in the length. They don't always do it in in the diameter. And then you have the laser systems, which are super expensive. They also go in the machine. They can be used for measuring runout, but again, I would say that a laser, although they say theoretically a very, very accurate measurements, we don't think they're as accurate as a vision system could be. So the presetter, if it's a good one, would be the first choice, and certainly our recommendation for every tool change that you make. The next question, could the new automated boring adjusted tools be used for large backspot face and tight bores with multiple adjustments? That's going to be a tricky one because we now have to move a tool into a hole, and theoretically it could do that. You could control the tool to be at its minimum diameter, feed through the hole, and then adjust the tool back to a larger diameter, like a counter bore, a back counter bore, back bore, and feed the back bore. And the problem we're going to run into, though, is it's going to be a little harder to get a large difference between the back counter bore and the entry hole. So, for example, if the entry hole is 3 inches, it's going to be a little difficult for us to move that tool all the way out to, say, 5-inch back counter bore because we have a limited space on the size of that boring head. Theoretically, everything can be looked at, and it would have to be something on a case-by-case basis. And the next question is, can the new automatic boring head do diameter adjustments between holes, or a 1.1-inch diameter, then adjust to the next hole 1.125-inch? Yes, the answer is you can do, if we have a tool within that range, we can do any different diameters with the same head. And that one boring head, as long as it fits the range of that head, can do any workpiece as long as it has the right length in a similar way that you would program a lathe. So, for example, if you're thinking about bores and lathes, you try to find the longest boring bar and the smallest one that fits the widest range of holes that you might want to put through that machine. So in theory, you could, if you already have, say, 10 boring heads to do all the work pieces that go across that particular machine, you might be able to see one boring head do them all and adjust all the way in between any size. So this would all be controlled by the program, just like you would programming a lathe. The next question. I have heard of over tightening a screw on hydraulic chuck can damage the life and the accuracy of the holder. Is that true? Thank you, Mark.
Jack, would you mind taking this one? I think you might have more experience with that situation.
So to answer the question, can you over tighten the screw on a hydraulic chuck? It will possibly cause trouble because you're going to ring it into the holder itself very tightly, and of course whatever gets tightened has to be loosened. But in theory, you're not going to do any damage to the bore of the tool holder because the screw itself is coming to a dead stop. It's not a set screw. It's actually a socket head type screw with a special taper on it. But because that locates into a socket and comes to a dead stop, you can't over travel the clamping chambers. So you're not going to damage that part of it, but what we see is more and more that the screws get broken. And if they're broken or stripped in a tightened position, we have very difficult time to get that screw back out. So you're probably going to have to try to drill it, or we're going to have to try to drill it, and it gets very expensive. So at the end of the day, yes, do we need to use torque wrenches on hydraulics? Probably not. But if you're trying to control the possibility that screws get damaged or stripped, then put torque wrenches on them so that they can't be over tightened them. And of course, replace those screws when you start to see that they're becoming worn. Next question. We're doing on time. Okay. Does Big Kaiser repair hydraulic chucks that have a damaged bladder? John? Cory?
That's not something I have experience with, but I believe that when the bladder is damaged, at that point, the holder cannot be repaired. So if you can no longer, if, for example, if someone tightened the screw with no tool holder or no cutting tool inside the holder, that could cause permanent damage to the internal bore of the holder.
That's absolutely true, Cory. And if I can expand on that, the way that these are built is you have the outer body of the tool holder and then a inner sleeve, which has the chambers built into them that eventually get filled with fluid. And these two are assembled in the heat treating process. So basically, they're put together permanently, and to get the bladders back out is not possible, nor practical. So unfortunately, if that part of the tool holder does become damaged, it is a throwaway part at that point. It's not repairable cost effectively. Next question, how does a presetter measure runout versus just size? Does it measure the diameter of the tool near the holder and at some specified distance from the holder and then compare? Would you guys like me to take that?
Yeah, I think so.
All right, so the presetter can give you absolute and incremental accuracies. It can measure both. It can measure what the theoretical diameter is, which includes the runout, or you can take a base measurement, say at the base of the tool holder, and move in the z-axis up towards the tip of the tool and see how that compares in an incremental value as you're rotating the tool. So it will make all types of total diameter runout comparisons. Whereas on the machine, it's going to be a little more difficult. There's an opinion question here from Ms. Bailey. Do you think retention knobs are all created equal?
I can take that one, Jack. I would say the answer to that is no. A retention knob puts a high level of importance on the tensile strength of the material that's used to produce it. And I have a good application example where a customer was using a rather heavy tool. It was an angle head, and they were experiencing significant chatter with their cutting tool, and they couldn't identify why. And as a last resort, they had purchased a new retention knob from a different manufacturer, and simply changing retention knobs eliminated the chatter in the cutting operation. So what they had found was their previous retention knob was stretching because the material wasn't made from, or the retention knob wasn't made from a material with a high enough tensile strength. So there is definitely importance in that part of a tool assembly.
Okay. Next question we have is, what is your recommendations on whether running Big Plus tool alongside standard tapered tooling at the same time? Is there a chip issue on the flat? So if I could expand on that question, can you mix and match Big Plus with non-Big Plus tool holders on the same machine in operation?
I can take this one, Jack. So as you saw in Alan's portion of the video, yes, Big Plus is backwards compatible with standard versions, so BT as well as CAT versions of the spindles. Contamination of the spindle interface is something that machine builders have attempted to address. So for example, some of them will include air blow-off nozzles that will blow across the face of the spindle. Most machines by standard will have an air blow coming down through the throat of the spindle to clean the taper interface. But when you order the machine as the Big Plus version, They will then add an additional nozzle that will blow across the face to clean the tool as well as the spindle face. Some machine builders have also gone to the route of having a confirmation circuit built into the spindle interface that limits your ability to use Big Plus or non-Big Plus tools. That is dependent entirely upon the machine builder. From our standpoint, we consider the system completely backwards compatible. But if a machine builder chooses to make their machine Big Plus only, then that is up to them and how they choose to process the tool change process.
Thank you, John. We have time for one more question, which I think I'll try to field. It's what are the options for HSK F63 long reach? Long reach meaning 6+ inches from the gauge line. Holders are fairly limited. What would be a recommended solution? What are extensions that would be recommended for applications up to or over 18,000 RPM in these types of situations? And HSK F63 is, you may or may not know, is a high-speed spindle tooling solution, and it has a fairly limited amount of torque transfer, but it's also a very delicate spindle from the regards of heavy roughing. So we've strategized on our lengths based on theoretical bending moments that spindle can handle. Now, that being said, doesn't answer your question. If you need tools which do go beyond, say, the 6-inch standard reach, we have now the solution using hydraulic clamping, where we take a base hydraulic tool holder of, say, 20 or 25 millimeters, short as possible, and now we have straight shank hydraulic chucks that go into that. So you can theoretically make some fairly long extended reach tools, and we like the hydraulic solution because it gives the best option for assembling two components as rigidly and accurately with regards to balance as we can possibly obtain. That being said, the balance, of course, would still need to be checked and dialed in just to be sure that everything's running true. Same could be said, you could do that with shrink fit. We use shrink fit straight shanks. We also offer those, which can be combined with a base HSK F63 shrink fit tool holder. These two solutions would be very good ways of putting that system together for high speed. The other with collet chucks and milling chucks is possible. Again, they also offer extensions like the Mega Micro. But probably our least favored option would be something that's modular, especially if it's some sort of a milling operation where we want to put larger end mills or face mills onto an extended reach tool holder. Again, we're primarily concerned with the safety and exceeding the bending moment limits for some of these tools and machines. And I think we're about out of time, and I want to thank everybody from Mike to Chris and Alan, John, Matt, Nick, Pat, Zach out in repairs, and Alan and Matt. I got to get all these guys. But I guess what you don't realize is we tried to put all this together virtually, but also keeping ourselves 6 feet in distance. And it's been a little bit of a challenge, but at the same time, we were able to pull it off and make a really nice presentation for our breakfast and learn and keep the tradition going. So I'm going to turn it over at this point to Gillian, and we'll close this meeting.
Thanks, Jack. Thank you, everyone, for attending today's virtual Breakfast and Learn. If you have any other questions, please contact us at bigkaiser@us.bigkaiser.com. Once you leave today's webinar, you will receive a survey on today's presentation. We would appreciate if you complete the survey and provide your feedback so we can improve future webinars. You will also receive a recording of today's webinar within 24 hours. On behalf of everyone here at Big Kaiser, thank you for joining us today and have a great rest of your day.